Hi folks, we're going to take a look at number 8 from page 497. So they want us to find the intersection between these two lines if there is one. Okay, so first thing I'm going to take a quick look at is the two direction vectors, and I notice they're not parallel, so I know these lines won't be parallel and distinct or won't be collinear. So it means they're either intersecting in a point or they're skew. Okay, now one thing I notice here before I start doing this question is I notice that the z component of the first direction vector is equal to 0. So I'm actually going to start working with the z's because I've got the one at the top that's much easier. So let's start working with the z's here. So from equation 1, I see the z value is always equal to 2. Okay, and I know it's going to have to be equal to the z value from the other one, so 8 minus 6s. And what's great here is that I don't have a t value, so I can just solve for s right off the bat. So I'll bring the negative 6s to the other side. So 6x equals 8 minus 2 is 6, so s is equal to 1. Okay. So now I could just take any one of the other components to solve for t. So take a look, and it looks like maybe x looks a little easier than the y. Okay, so if I work with the x's now, from the top equation, I've got 3 plus m equals, and from the second equation, I've got negative 3 plus 7s, so negative 3 plus 7, although I've already established that s is equal to 1. Okay, so it makes it a lot easier. So here, m is equal to, so negative 3 plus 7 is 4, minus 3, bringing that to the other side, m is also equal to 1. Okay, so the parameters that solve the x and z components are I think this was equal to negative 3 plus 4 is, negative 3 plus 7 is 4 minus 3 is positive 1. Sorry about that. Okay, so they're both positive 1. Okay, so let's see if it works for the y components. Okay, so if we take y, I'll call it 3 from equation 3. What do we have? 7 plus m times negative 6, so 7 plus m, which is equal to 1, times negative 6. That gives me 7 minus 6 is 1, and then from y4, we have 2 plus s times negative 1, so 2 plus s, which is equal to 1, times negative 1. So 2 minus 1 is equal to 1. Okay, so we see that these components, or these parameters give us the same y component. So that means that there is a point of intersection. Okay, so this is definitely what we're looking for. So we know the y value is equal to 1 already. So let's determine the x value. Okay, so the x value, well, I can use 3 plus m here. So x, that's from the first one. So x is just 3 plus m, which is 1. So 4. So our x component is equal to 4. Our y component we already saw is equal to 1. And our z component, what we saw from the first equation, has to always equal 2. Okay, and so there's our point of intersection. Okay, so this is a little different from sort of our usual point of intersection problems because we are actually able to make our lives a little easier by noticing that this 0 as a component for one of the direction vectors made the solving a little simpler. Okay, so be sure to look for that. That's it for this one.